Bohr's shell model is a theory to explain the line spectrum of hydrogen atoms. In the 1900s, the physicists at that time discovered that the hydrogen atoms can only emit or absorb certain wavelengths or frequencies of the electromagnetic radiation. At that time, the physicists only know Newtonian physics, therefore they do not understand the phenomena they observed. At that time, Niels Bohr, a Danish physicist, invented this theory. Now, we call his theory Bohr's shell model. It has three postulates. Postulate 1 says, only orbitals of certain radii are permitted for the electron in a hydrogen atom. The permitted orbitals are labeled as n equal to 1, 2, 3, until infinity. N equal to 1 orbital is the closest to the nucleus. Well, this is a two-dimensional representation of the orbitals in the Bohr shell model. The center is the nucleus. This is n equal to 1 orbital. This is n equal to 2 orbital. Each orbital has a fixed radius. We cannot change the radius of each orbital. Apparently, the atoms are three-dimensional structures. Therefore, the orbitals in the Bohr shell model actually are spherical surfaces. From the postulate, we also know that an electron can only stay on an orbital. It cannot stay in between the orbitals. Well, let me repeat. An electron can only stay on an orbital. It cannot stay in between the orbitals. Well, let's look at the second postulate. It says an electron in a permitted orbital has a specific energy, and we say the electron is in an allowed energy state. The energies can be calculated by this equation. The energy of the nth orbital is equal to 1 divided by n squared multiply negative 2.18 times 10 to the negative 18 joule. From this equation, we can see that when n becomes larger, the value becomes larger. Or we say that the value becomes less negative. Therefore, n equal to 1 orbital has the lowest energy. The larger the value of n, the larger the energy of the orbital. Well, let's continue to look at the second postulate. An electron can remain in an allowed energy state without emitting or absorbing energies. Well, at that time, from Newtonian physics, when an electron is moving around a circle, it will not be stable. But since we do not know enough Newtonian physics, you should not have a problem to accept this fact. Therefore, do not try to understand this fact with Newtonian physics. Now let's look at the third postulate. It says energy is emitted or absorbed by the electron only as the electron changes from one allowed energy state to another. This energy is emitted or absorbed as a photon. This is the mathematical equation for postulate 3. It says the energy of the high energy orbital minus the energy of the lower energy orbital is equal to Planck's constant multiply the frequency of the photon. We know that Planck's constant multiply the frequency is equal to the energy of a photon. Now let's look at some illustrations. Let's look at figure 1 first. An electron was on n equal to 2 orbital. Then it jumps from n equal to 2 orbital to n equal to 1 orbital. As we know, n equal to 2 orbital has higher energy than n equal to 1 orbital. Therefore, the energy difference or the energy loss will be turned into a photon. The energy difference between the two orbitals is equal to the energy of the photon. The energy of the photon is equal to Planck's constant multiply the frequency. Now let's look at a different representation of the same phenomena. The electron was on a high energy orbital. When it changes from high energy orbital to low energy orbital, the energy difference or the energy loss will be turned into a photon. The energy of the photon can be calculated by using the Planck's constant and the frequency. The energy of the photon is equal to the energy difference between the higher energy orbital and the lower energy orbital. Now let's look at a different scenario. Figure 3. An electron was on n equal to 1 orbital. If a photon has an energy that is equal to the difference between n equal to 1 orbital and n equal to 2 orbital, the photon will be absorbed by the atom. Then the electron will be on n equal to 2 orbital. However, if the energy of the photon is equal to the energy difference between n equal to 1 orbital and n equal to 3 orbital, the photon will be absorbed by the atom as well. Then, after absorbing the photon, the electron will be on n equals 3 orbital. In a different scenario, suppose if there is an electron on n equal to 2 orbital at the beginning. A photon that has an energy that is equal to the energy difference between n equal to 2 orbital and n equal to 6 orbital. Then the photon will be absorbed by the atom. After absorbing the photon, the electron will be on n equals 6 orbital. Well, let's look at a different representation of the same phenomena. If a photon that has an energy which is equal to the difference between the lower energy orbital and the higher energy orbital, the photon will be absorbed by the atom. Then the electron will change the orbital from lower energy orbital to higher energy orbital.